So either use a SaaS product already, like that can just, you can point and click and do things, or just use the cloud's native environments for CI/CD.
Thanks everybody for joining us. So this is our series of XgridTalks where we'll talk about different technology topics. Today we have Dr. Ali with us. He has his PhD from Michigan University in software-defined networks. He started his journey as a design engineer, went into academia. He has hundreds of publications under his name. He has worked as director of engineering in many Fortune 500 companies, and currently he is working as GM for SDN and Internet Monitoring at AWS. So thanks a lot for joining us, Ali. Let's start with the session. So in this first round of series, we'll talk about DevOps, do's and don'ts, especially for the startup founders. So again, we are very much looking forward to our discussions with Dr.
So Ali, thanks a lot for joining us at XgridTalks. We'd love to have you here. So let's just start off with our discussion. So what is DevOps and CI/CD?
Thanks for having me, Saad. And I would love to talk about DevOps. DevOps is a concept. The concept essentially is based on a philosophy. The philosophy of software engineering that DevOps preaches is that you build it, you run it. So for the longest time in the software industry, people would write software and then they'll rely on some other team to test it, and some other team, yet another team, to actually run it in production. DevOps changes that by shifting that responsibility to the left, to the developers. If you write a bunch of code, you're going to run it in production as well, which means when it breaks, you're going to get paged. So that's the foundation of it. That's the concept that DevOps brings to the table. Now, this concept isn't necessarily new in itself. Some teams are already doing it, but it's become much more widespread with the introduction of the cloud, where you don't need a lot of infrastructure teams that have to manage a lot of servers and other types of compute and networking gear. All of that is taken care of with the cloud already. So it becomes even more relevant that the people who are writing code are actually running it in production as well. Generally, it's not that a person who writes the code, him or herself, is running it in production, but the team is responsible for running the entire code in production, and the entire process of testing, building testing, as well as operating the code in production is shifted left to the developers.
Okay, that's very fun. So in terms of CI/CD, how would you define it? How would you sort of like, what's the relevance over here?
So CI/CD is just an enabler for DevOps to really take place, right? CI stands for continuous integration, CD stands for continuous deployment. So continuous integration is nothing but earlier in legacy software, people used to have these big QA teams who would just click on buttons and do things manually to test that a particular piece of software was working as expected. There was like this humongous test plans that had to be run in spreadsheets or the tools that were used to make sure that those tests get run. CI actually again shifts that responsibility to the developers, where the developers now have to write automated tests. And you run those automated tests on every check-in or every code commit that comes into your repository. As soon as that code comes in, you run those tests, and you've got a bunch of those tests telling you that this new commit that came in is not introducing any regression in your existing code. So it gets merged automatically. All the packages that need to be built get built automatically, and you have all the regression tests that are run automatically as well. In any of these processes, if something breaks, so for example, any of the tests are failing, or if any of the build processes are not acting as expected, CI just stops that commit from getting merged into the repository. So CI is just a concept which is a build and test process, and it relies heavily on removing humans from that pipeline. CD is the next step for the thing that you build. So you tested it through your CI system, you built it, it seems to be working. It seems to be working in your emulated test environments. CD is actually the process of, if you really believe these tests are valuable and they are representative of the health of your system, then you deploy it automatically as well. So whatever passes through your CI pipelines gets deployed in your production environments right away. So which means you could put some gates between the CI and CD systems, but essentially anything that passes through CI just gets deployed automatically in production. If you got stacks in multiple places around the world, it'll just roll out to all of those places without a human having to intervene with any of that process.
So let's just assume that companies are shifting toward DevOps. So I think that's the case. So what are some of the benefits that they are getting out of it? And can you discuss more on that? Why
the biggest benefit is,
the
biggest benefit is we don't need those humongous QA teams anymore. So I think that's a big advantage, especially for startups, right? For smaller companies, that's one advantage, that you just need fewer people who are doing things. You're using automation to save headcount. So you're putting in a little bit more effort right now, but you're saving much more time and energy that would be spent otherwise if you wouldn't put in the effort into automation. So that's the big advantage. But I think that beyond that, the more important advantage over here is the philosophical advantage, right? The ownership that comes with it. Traditionally, if you worked in any company that built software and they had QA and dev teams, it was just always they were headbutting with each other. There was always friction. The QA team didn't really understand the feature that they were testing. The developer didn't really build it to the specs that the customer provided. And there's always this back and forth between these teams that have traditionally become a topic of many memes on the internet. So philosophically, that just didn't make sense. That's a very broken ownership model, right? And in a world where all the test frameworks and automation and compute wasn't easily available to us, it makes sense. But in today's day and age, why do it? Why have that split ownership model of 3 different teams? One of them building it, the other one testing it, third one operating it. And I think that philosophy and the concept, engraving it into the company's software DNA is a very valuable thing in and of itself, in addition to saving headcount on with automation rather than spending it on people doing manual processes repeatedly.
That's good. So let's just suppose I have a startup. Okay, I'm building an MVP, or I have an MVP. So it's maybe a monolithic application or whatever of that sort. So where do I start? What are the next steps in terms of going to this DevOps journey?
So if you haven't already done it, you've probably been living under a rock. So this is you would start off by just reading up on the internet, I would say. So this is a pretty well-known concept at this point, and the problem is not that the information is not available. It's just that too much information available. And how do you start is, if your team is not already doing it, the first thing is to get your team onboarded. But this is going to be a different concept where the developers are not just responsible for building the software and only the unit tests, but they're also responsible for building functional and system tests as well. And automating every test that they write, they have to be able to automate it. And once they automate it, then there are many technologies that are available. And over there, it becomes a complex matrix of which one you pick to build your DevOps pipeline or your CICD pipeline. It really depends on your use cases. If you are based on a private data center and that is your key, all of your workloads are over there, then you'll have to pick a system that is based on Jenkins or something else that you could actually roll your own. And there are also some other companies that are doing it. If you are a cloud-based system, then you got many more options, because you got the clouds. Each of the clouds also offer, public clouds offer some sort of CI/CD systems themselves. Every one of them offers them. And then there are many other out there in the which are being offered as SaaS platforms as well. On CI, you've got Circle CI, Travis CI, there are many others, right? So on the CD side, you've got Argo CD, you've got Flux CD, you've got many other systems as well that just do the continuous deployment for you as well. So it really depends on your use case and where your workload is situated. You mentioned something around a monolith. A lot of people think, if I've got a monolith, I can't start DevOps and I need to wait for it to be broken down into microservices before I can do something meaningful with it. I think that's a fallacy. You really don't. You can get started by But whatever you have, I'm like, got some test cases, and there's a test framework out there. I show you of that can automate those test cases. And if it doesn't exist, it's probably a worthwhile effort to hire engineers to build that test framework rather than having them run manual processes to run those tests. So don't wait for, my big advice to a startup is don't wait for your application to become the shiny new, fully microservice-sized API-driven application before you start your DevOps journey. Just start and then iterate on it. It's an iterative process. Start right away, talk to your team, and pick the technologies that are that'll work for you today, and then iterate to make it better and more scalable in terms of your application architecture.
Okay, so as a founder, obviously I'm starting this journey right now. So there are different sort of like there are the SREs, cloud engineers, and all of those like titles are there. What kind of profiles I'm looking for? So I would assume there's a strategy part. We have to do some architecture, then we have to like build, deploy it, then we have to maintain it. So what kind of people should sort of like come in into different cycles?
So I have no idea. I mean, there's so many different terms used for the same thing. I'm like, I'll be honest with you, reading those. So people call them DevOps engineers, site reliability engineers, cloud engineers, infrastructure engineers. So there's so many different terms. I could tell you the layers of this of the software stack where they operate generally, and that is probably a much better way to think about it. Because even I can't, in this deluge of acronyms, I have no idea who does what. But essentially, at the core of it, you have some people who are owning the infrastructure, which runs applications. That infrastructure is your virtualization infrastructure. It could be a container-based virtualization infrastructure. It could be a cloud-based virtualization infrastructure. It could be a VM-based virtualization infrastructure. But there's some sort of an infrastructure that abstracts away the server, the hardware servers, and provides an easy orchestration layer on which developers can write their applications. So there is definitely a job family that caters for that. They are called cloud engineers if everything is on the cloud. They're called infrastructure engineers if you're doing some sort of an on-prem deployment as well. That's one piece of it. DevOps, I think, is a concept. So every developer should be a DevOps engineer. I don't think there should be a separate, like at least philosophically, I don't think there should be a separate job category even saying DevOps. DevOps is a concept. If you're writing code, you're writing an application, you need to own testing it and running it in production as well. So for me, that's a concept, but I know that that's become a job family as well. But for me, it's a concept. Then comes the concept of a site reliability engineer. So while the infrastructure engineer provides you the foundational infrastructure on which you're orchestrating your applications, and application engineers are doing the development as well as the operations, so the sort of DevOps piece of it, there is still a role for a team that can make sure that your entire infrastructure, all the applications and entire infrastructure is working as expected. And it is cutting across all the applications and all the different types of infrastructure that you might have. So you could potentially call them site reliability engineers. Some of the other teams are still calling them infrastructure engineers. So I don't think there's like a standard definition in the industry. But yeah, I've seen that anybody who has cross-cutting concerns in terms of applications and infrastructure, managing multiple infrastructure, different types of applications are generally falling in that category of making sure that everything is running as healthy as expected.
So you can always correct me if I'm wrong. So there's a huge advantage of automation in this entire sort of like this DevOps journey. So for us, for any sort of like startup or for any engineer to be comfortable with this automation, what's the path like? How do they go about doing it?
So I would say to get started, if you're really getting started, and this is actually a real problem. So I see some who are brilliant who are not able to make this transition. So if you're an engineer, you write code in any language, be it Java, JavaScript, Go, Python, in whatever language you write code, and you've not made that mental transition that I'm going to actually not only just write the code, but also write automated tests and run it in production to a CI/CD system, you're getting left behind. So this ship is already sailing. So I think the engineers need to get into the mindset of, we're not just people who are building, but we actually have to operate it in production as well. And that puts a very different type of mindset for the whole team as well as the engineers. So I would say where you would start is, if you're really starting your journey, I would just not try to roll your own and maybe use a cloud-based solutions, because it's just easier. There's a lot of information and help that is available, and help you get familiarized with the concepts and setting something up pretty quickly. So either use a SaaS product already, like that can just, you can point and click and do things, or just use the cloud's native environments for CI/CD. That'll be the easiest and fastest way for you to ramp up. The mental models that you built as an outcome of that effort would be portable. So if you want to do a DIY private data center on-prem solution, the mental models are still the same. Like the abstractions are still the same. The technologies might be a little bit different. But if you're just getting started up with a SaaS offering or a cloud-based, native cloud-based offering, because that'll be the easiest and fastest way to get started with this journey.
Okay, so now just that's a continuation of that question. So where does QA fits in all of this DevOps? So it goes back to separate QA engineers, or is it like the developer has to become a QA engineer also? What's the role of QA in all of that?
It doesn't fit in. So that's the whole point. Like if you're a purist, it doesn't fit in. That's it. Okay. There is no QA engineer. It doesn't. This concept is borrowed from the hardware industry, and this concept is not like it's somehow crept into the software industry as well, but it doesn't have really an equivalent function in other industries. So I mean, like I could tell you in Amazon, there's no QA function. Like you write your software, you operate it in production, you write the test cases, you own it. If you write bad software, you are going to get paged in the middle of the night. Worst, your team member is going to get paged in the middle of the night, and his or her spouse is going to be hating you. So that's the culture that you want to propagate. And so yeah, there is no distinction between somebody else testing your code versus you writing the code. So the engineer is supposed to understand the customer use cases, understand how he or she needs to test the software, and then automate it in the pipeline as well.
Okay, so everything is with the coders now. Okay. So infrastructure and everything, QA and everything is with the coders now. So that's like the
so everything is with the coders. That's the purest view. Now, of course, it doesn't work that way. It doesn't work in 70% of organizations, but that is the purest view of it.
Okay. So in terms of so you're on with this DevOps journey, you're working on that. What kind of KPIs should be there?
So again, I mean, like for me, DevOps is a concept, and every engineer is a DevOps engineer, and every engineer in the world of today's world of software development should think of themselves as a person who's not just developing, but also an operator as well. So the KPIs then would be the same as they would hold themselves accountable to, like the application uptime and applications performance, which could be transactions per second and latency of API calls and whatever those KPIs are. So I would just say, how many times did you break stuff? Like it could be a KPI. So don't break stuff up. So I would say it's the same KPIs. I mean, like I don't think anything fundamentally changes over there. Just the responsibility shifts left to the developers. Now, the SRE engineers or infrastructure engineers who own the infrastructure could have other metrics as well, which are we could call them output metrics for them. For example, their job is to make it easier for folks to write automated tests. For example, that's one job that infrastructure engineers have. They could measure themselves in terms of how easy is it for somebody to write a new test. So from a specification or document, how quickly can people convert those into tests? I mean, they could write those kind of things. And they could also have metrics around, how is the infrastructure? Is the infrastructure meeting? They can have SLAs around infrastructure, and whether the infrastructure is meeting those SLAs in terms of not just uptime, but also scalability and reliability and performance that they could define upfront and then hold themselves accountable to it.
No, okay, thank you. So let's just suppose I have a SaaS startup and I'm setting it up. So which approach is better, like using Jenkins Cloud? What would you recommend?
It depends on your use case. I mean, where's your workload situated, right? So you gotta bring the CS system that works for your workload, right? So I would start off with your use case and your workload. And many organizations today have hybrid workloads. Some sitting in on-prem systems, and some of them sitting in the public cloud. Some of them are completely in one cloud. Some of them are in multiple clouds. So I think it really depends on what your use case is. If you do have hybrid environments, then then it just makes sense for using something that is more SaaSified, either from a native cloud or a SaaS company that can connect all of those dots together. If you're all on-prem, it'll be cheaper for you to roll your own using Jenkins and a CD system that there's a lot of automation that's been built on top of Jenkins to continuously deploy to your environments. So if you're all on-prem, then you would go with a Jenkins Spinnaker type of a mix. If you're mostly on cloud or a hybrid of different clouds or a hybrid of on-prem and cloud, then I would recommend that you go with a SaaS offering, either which is cloud native, offered by a public cloud, or it's offered by another company, but it is still an API-driven SaaS service.
So let's just suppose I'm just bootstrapping. So there are like 3-4 guys who are sort of working on it. So am I correct when I say, okay, cloud native is the best option for them?
Cloud is more expensive, so it depends on how much money you've raised.
Okay.
So if you've raised enough money, I would say that's the fastest, cheapest in terms of people that are going to have to work on setting it up. So yes, so taking something from the public cloud is going to be the fastest way to ramp yourself up. It's going to be probably a little bit more expensive, but generally that is what I would say is the easiest and fastest way to get bootstrapped.
Mm-hmm. So infrastructure as code. So that's maybe the underlying theme for the DevOps. Is this correct?
Yeah. So infrastructure as code is like taking DevOps even further, right? So we've so far talked about code comes in, code gets tested, code gets built, code gets deployed, right? So that's the pipeline that we talked about. But like I was saying, the infrastructure engineers, their job is to sort of like make sure that things are scaling out when necessary. They can set up stacks in a particular, let's say in a cloud, in a particular region of that cloud, and then they can also build a stack in another version of the cloud as well, or other region of the cloud as well. So if you start doing it through point and click, it will take you forever to build it, and it's human and it's error prone. So every cloud provider, every SaaS offering provides you an API surface. So if the API surface is there, then people wrote a lot of automation on top of that API surface to write a code that will actually bring up the infrastructure. So if you're doing it in one region, you just change the name of the region and the same stack could come up in another region as well. That has become even more programmable at this point and flexible, because there are high-level abstractions in terms of simple languages, config-based languages that have been built that you don't even need to know there is an API call at the back end of it. So you define that as code, which code earlier used to be APIs. Now it's just basically defining some sort of a configuration file. And the configuration file gets compiled into those API calls that need to be made to bring up your VMs or bring up your load balancers and any other infrastructure component that you need to bring up, whichever region you want to bring it up in. So infrastructure as code is just that you define, it's an abstraction on top of the infrastructure that you're going to be using. And the beauty of putting everything in code, even every single infrastructure component that you have in code, is that now if you need to replicate it, it's very easy. It's not human driven, so there's no chance of fat fingering something. It just happens automatically. If you have breakages in your infrastructure, it comes back up through the same mechanism. So it's much more predictable, it's much more reliable because it's still machine driven. So yeah, that's a fundamental concept that I think, again, DevOps is a concept, so I'm not going to go in there, but infrastructure engineers have almost all migrated towards managing all of their infrastructure through IAC rather than doing it through point and click at this point.
So is IAC as fundamentally adopted, or is there's still hesitation, or there some companies are there or not there yet? So what's the
IAC,
sort of like?
IAC is very widely adopted. So IAC does not like the friction that exists, somebody losing the job, the QA function disappearing, does not exist in IAC. It's just solving a real problem, a real pain. So IAC is very, very widely adopted. People are using different technologies for it. Like if somebody's on AWS, they're using CDK or CloudFormation. Other people are using Puppet or Chef or Ansible. There are different technologies. People prefer different technologies, but the concept itself is very widely adopted because solving a key pain, and it is removing misconfiguration from hitting production environments. The DevOps concept is much more disruptive because it actually it impacts different job families. There's a traditional way of doing things, and that needs to change. There's a cultural transformation that comes with it as well. IAC is much less controversial and much more widely adopted as a consequence.
So for a startup guy, somebody who's actually just getting onto this journey, so IAC is a must. Like they should adopt it as soon as possible.
Absolutely. There are no questions asked. It's actually faster. I'm like then point and click, right? So it's faster than point and clicking at things. So there's no reason not to put in that investment.
Okay. So so somebody has a startup, and now there are different options available. So they have the AWS and GCP and all of those vendors. Which one to choose? Which one is the best one? Are there any differences?
Hey, you can't ask me that question. I work for AWS.
Yeah. So maybe AWS is the best.
I work for AWS, but everything I said in this interview is my personal opinion. By the way, no, there's no easy answer to this in terms of features. AWS is ahead, and so there's no easy answer to this. It really depends on your use case. Different clouds have different things that they want to offer. There's no one size fit all here.
Okay. So let's just say, I think from this discussion, AWS is the best. So that's something.
I didn't say that, but yeah, if you took that away, great.
Okay, that's
more job security for me.
So now let's just come towards the tech stack part of things. So in terms of cloud management, security, automation, IAC, what are some of the options, recommendations, and in that regard?
Again, you gotta start off with where your workload is, and everything is dependent on that. This is a very deep question in terms of which ISC should you choose. So if you've got multiple options, if you're in the cloud, you could pick on AWS, you could pick CDK or CloudFormation, which are both native, but CDK is the new generation. So I would just say go to the new generation and try to start up over there. But also, even in the cloud, you could use Puppet or Ansible or Chef. Each one of them comes with a pretty deep set of very rich features, and they offer more or less equivalent functionality. But one of them is sort of based on, for example, Ansible is based on SSHing. It's got an SSH infrastructure, which is very easy to set up, and then it just manages everything through SSH commands and provides an automation abstraction on top of that. Puppet and Chef are more full-blown languages that have their own management channels and the separation of config versus everything else in code. So it really depends on what kind of engineers do you have and how long do you have to bootstrap these things. So IAC, I would say, pick it carefully and pick it based on what kind of skill sets do you have, how much time and effort you want to spend on it. If you want to go Puppet or Chef route, it's going to take you longer to onboard people, but you get much more flexibility. Whereas you're going to go with other solutions, they're easier, but they're not as feature rich. In terms of security and automation, on automation, there's like automation. I believe you mean whatever test infrastructure you're using. Again, depends on your application. Is it like a front-end application? Is it a back-end application? There are different which languages it's written in. But yeah, the good news is there's a gazillion test frameworks, and all of them are open source. So very easy to go adopt one. But yeah, it takes a while to figure out which one to use. There's probably too many options. In terms of continuous integration, continuous deployment, again, depends on your environment. If you're fully on-prem, probably be cheaper for you to start off with Jenkins and deploy from there. Use CD frameworks. Many of them work on top of Jenkins very seamlessly, so it'll probably be easier for you to set that up, or cheaper for you to set that up, even if not easier. If you're in the cloud, then again, cloud and Jenkins is not mutually exclusive. You could have Jenkins on the cloud as well. If that's what your engineers are familiar with, Jenkins offers that service on the cloud as well. It's very easy to set it up on AWS or any other cloud. Or you could use the more native technologies like code deploy or code pipelines that AWS offers, and every other cloud offers something equivalent as well. So again, depends on your use case. Security and cloud management are tools in themselves. So like, so for example, cloud management, I would really recommend using whatever natively offered by the cloud. It's much better integrated. Now you get a much better experience. Like for example, CloudWatch in AWS would give you much better experience and much more feature-rich experience than if you got something from the outside. For application performance management or monitoring, you could have other solutions, but for cloud itself, the infrastructure monitoring, generally the cloud solutions themselves have the best support for it. Security means a lot of things to a lot of people, so it really depends, but security is generally always a layered construct. Like, so you got basic security that you will implement using cloud native primitives, but then there's some sort of a policy layer that comes on top of it. Then there's some sort of a layer for communication or anomaly detection or intrusion detection that comes on top of it. So it's generally a multi-layer strategy. There are SaaS providers, there are cloud native solutions. So there's a lot of things that happen over there. There's no easy answer. You have to see what's best for your use case.
So it seems like there's a buffet of options out there. So it's just like putting those Lego pieces together. Somehow there has to make sense as per the use case. So that's should be an easier job, but it has also become fairly difficult with all of the options that are out there. So, I mean, so any tips on that? I mean, or is it like, okay, find the best architects who have already built it and talk to them and try to hire them?
Yeah, no, I would say hire people that have some experience of doing this. If you do it from scratch with people that don't know how to do this, you'll basically end up repeating mistakes that a lot of other people have already done. So in terms of your team's composition, I'm like getting people who have experience of building code in a CICD fashion, or infrastructure engineers who have actually built ISCs at scale would be a very good investment to make as a startup founder. And early on, these are investments that if you make them, it pays big dividends in the long run, because you're saving on QA cost, you're saving on infrastructure cost, you're getting better reliability, better visibility into your infrastructure as well as your application's performance. So yeah, that's a worthwhile investment. Generally, the good news is that these engineers, if they've worked in this space for a while, they have inevitably been exposed to like 5 different things already. So they all generally know, many of them generally know Terraform as well as Ansible, as well as CDK. So just because by the nature of this thing and by the nature that workloads have just gotten spread across multiple locations and on-prem versus cloud versus something else, they are reasonably familiar with multiple technologies already. Even if they're not, if they know one, they're easily able to port that skill set to a new technology as well, or make the right judicious calls as to what your workload would really require. So that knowledge is there, but you're right, there's a deluge of information out there. So the challenge is not lack of information, the challenge is too much of it.
So obviously somebody, so for startup is a different case, but somebody who's in the middle of it and they want to get onto this DevOps also. There's a lot of, I think there's a huge cultural change that needs to happen. And I think maybe you can actually talk more about that. What needs to change and how to go about doing that?
Yeah, so I think there's a huge cultural change. I mean, that's probably the biggest part of this whole puzzle. I mean, like, it's not the technology piece. Technology is easy. People are hard. So that's where this needs to start. I'm like, if you can't get your people aligned around this, this will never happen. Or they'll just check some boxes, and you really wouldn't have gotten the benefit, the business benefit, or the cultural benefits that you wanted to achieve from these kind of initiatives. So I would say, yeah, the earlier you start, the easier it is for you to build that culture. I would say the first person that you hire should be a very strong background in, building things which have been built through automation, and developers owning their own codes all the way from building to testing to operating. But yeah, if you already have a team in place and you're inheriting it, best of luck. I think you're going to have to replace some people and bring in new people to be able to start this transition. I've seen a lot of friction. I've been in teams that did not want to adopt this because nobody wants to be patient in the middle of the night. But that ownership is exactly what drives the right behaviors in coding and testing. So it's not an easy journey, but if you are inheriting a team, getting a few strong people who can actually build this automation can very quickly and very effectively show the value of building this automation to the rest of the team. So getting those people in who have some experience of doing it is a must-have in this journey. So that's a investment worth making. And the earlier you make that investment, the higher the dividends are down the line as well.
Okay, so obviously we're living through this pandemic. So there's work models are evolving, changing. So it's not like so nobody's sure as to which direction will it go. Will it be like totally remote or flexible or hybrid? So I think DevOps should help with all of this.
Yeah, like everybody is going to be working from home, so they'll be committing code from home. That is going to be a thing of like few days a week at least. So
Okay.
having automated testing, so anybody who needs access to a certain set of hardware to run some tests is not going to be a thing anymore, right? I'm like, so I think that over there, it's a nice forcing function, and it's a nice incentive for developers to actually adopt some of these practices. That you automate everything that you can, and then everything is just running automatically, and people don't have to go drive over to a certain place to be able to test their code. So I think it does help in that sense, but at the same time, I don't think that's the biggest blocker to its adoption either. So proximity to test devices wasn't the biggest blocker to adoption of DevOps. It was the culture and developers being lazy.
So what's your sort of like feel like in terms of if you pick bigger corporates, small, medium businesses, and startups, what's the adoption rate of DevOps? Like, what's your opinion on that?
I don't think it's got to do with the size of the company. I don't think that's the right way, or that's not how the market is segmented. It is really how long that company has existed, whether it's small or large or medium. I mean, like I think that determines what they're doing it. But even over there, for example, Amazon almost came up with this concept of DevOps, right? Like they've been doing it forever. Netflix has been doing it forever. So they've been around for a while, but they've also been doing it since their inception. Whereas some other companies started with legacy software development, and they're slowly transitioning towards that. But yeah, generally what I see is companies that have existed longer are generally not that far along in their DevOps journey versus new companies. For them, it's just easier to start this way. For them, it's just natural to start this way as well. But again, exceptions exist. Amazon, Netflix, Google, many of these companies have this foundational to them. Facebook is foundational to them. So there are many companies who have been doing it from the start this way, but many other companies, more traditional vendors or enterprise plays, still are not very far along in the DevOps journey.
Okay, so as a startup, I'm sort of like shifting to this DevOps and culture and all of that. So I have these two different teams there. So obviously one handling the development part, the other having the ops part. Tell me what to do now.
So you probably, if you already have one development and one ops, you mean the QA function is separate from the development function?
Yeah.
I would start with, I mean, like, so QA engineers actually, like, so here is the dirty truth that nobody wants to tell you, but QA engineers don't want to be QA engineers. They want to be developers. Every QA engineer's dream is to become a developer, right? So I think that's where you start. Yeah, you say, okay, let's start off by automating as much of your daily job as you can. Nobody's going to argue with that, right? That starts them on a journey to learn more software. Then you say, okay, well, why don't we put this in pipelines and build and integrate every check-in that comes in? And I'm sure they'll actually, those folks already know how to do this, and it's very natural for them to make that transition. So instead of just bringing in down a big hammer, I would say the QA engineers actually want to be developers, and this is their path to shift left towards the development life cycle rather than testing somebody else's code. Once they build all the right infrastructure, they can start off by writing their own test cases, but then slowly you can transition, build the right abstraction, build a test infrastructure in which you can provide the right abstraction so that the developers can actually start writing tests and start shifting that left to the developers as well. Whereas what originally used to be the QA team now becomes your infrastructure team that is actually managing just the infrastructure. Easier said than done. I said it like as a joke. It's not. I'm like, I know it's not for the faint of heart, but yeah, I would start off over there. I'm like, the QA engineer actually does not want to be a QA engineer, and that works in your favor.
Okay. So that's a very good suggestion. So I picked QA engineers. They started the automation work, and so they're working on it. So what happens to the infrastructure guys?
Infrastructure guys exist, right? I mean, the IAC and managing the fundamental like physical infrastructure, physical instance could be in the cloud, but that team exists irrespective of everybody else, right? Somebody's got to wire everything up to make sure that even you can build test infrastructures on top of it, even you can write applications on top of that infrastructure. So that job family is, they don't have job security problems. That's the infrastructure as code, right? That team needs to exist anywhere. Like there's no ifs and buts about it. So I don't think that's up for debate. Now, a lot of teams have, if you're a very small startup, I mean, like when we started, I started my own startup as well. We wrote our own, like our developers wrote the underlying infrastructure as code layer as well. And for the longest time, they just maintained it themselves because we didn't have the money to hire another person or another team to do that. But once it grew big enough, I mean, like we had to hire that team to be able to make sure that on any cross-cutting concerns on application or infrastructure side are managed by this one team. So I would expect many startups to start this way. You know, the development teams will actually own the first phase of development of this infrastructure as code and managing that infrastructure, and then it'll just evolve into a separate team. So,
okay. So if I'm so again coming back to a startup issue, so I should hire guys who are actually who have these profiles who can sort of like do the coding part and do all of these automations, infrastructure and code. And later down the road, I need to have some separate infrastructure guys. So for the QA part, do I really need QA in this, or is it something which is not needed now in this DevOps culture, pure DevOps culture?
You really want me to say there's a place for QA in the DevOps culture? No, there isn't. I'm like, I'll keep the purest view. You can ask me this question another time as well. I'll say the same thing. I don't think it exists. That traditional role of a QA engineer does not exist in the DevOps world. You have, like I said, you have infrastructure engineers who manage the physical or virtual infrastructure. You've got test infrastructure engineer who write infrastructure on which you can write your test cases in a very productive way. You have developers who are writing applications and writing their own test cases. You have site reliability or more sort of like cross-cutting engineers who are actually looking at all the infrastructure and all the applications of them being healthy. But the fundamental job of this piece of code is going into production, and it's not breaking the application, and it's healthy, and it's not degrading its performance. Now must reside with the developer who wrote that code. Everybody else is supposed to provide abstractions and simplicity so that they can do their job more productively.
So maybe let's just wrap it up. So has DevOps made it easier for a startup founder to build their applications, or is it like now you need to find these superhuman guys who can do all of that stuff? So what's the sort of like, where is it tilting?
So DevOps has made it faster. I can say that conclusively. But the human mindset hasn't shifted. So there are two things over there. First of all, the developer's mindset hasn't shifted as quickly as how the technology has shifted from underneath them. So that's one aspect of it. The second thing is this has gotten almost next to no attention from universities. So, so students who are graduating absolutely have no idea what this means. Before they hit the industry, they have never heard these terms. They don't know what this means. And this is their first exposure to how to do really production grade software development. So I think those are the gaps that are, if the growth is slow, if you're not able to reskill existing developers, and if you're not getting people who know this upfront, that's the gap. This does not require a superhuman person. These are not really hard. It's not like learning a new language even. You know, most of these are like, I was saying, like all of ISC is generally in a YAML. It's just in YAML files. It's just config files. You're not even writing code. You're writing configuration. That's it. You're opening a text file and writing configuration. I'm like, so it's really gotten, the abstraction has gotten so good that it's become as simple as writing text in a configuration file. Many of the times. So it is not really that the technology is hard and you need superhumans to do this. It's just that the fundamental foundation where some universities are actually teaching it and getting people ready to join this workforce has not existed. And engineers who have developed in the legacy way, where they were relying on somebody else to do QA, are too lazy to go learn something new, or not even too lazy. It's sometimes there's just too much deluge of information and they get lost in it, and they like some
So
crazy
just
stuff. New kids
to
are trying
elaborate,
out.
yeah. So just to sort of like resolve this issue, so somebody who's been coding for a while and who's actually used to whatever with this QA and all of the structure, now they have to upskill. And obviously, you say there's too much information, but what would be your recommendation as to they should sort of like take a path, and what would that path be like?
So I would again start off with maybe start with learning about what would be the best thing to use for your workload. And once you do that, each of these companies, I mean, like they've spent a lot of time because nobody else is doing it. Yeah, every cloud company, every SaaS CICD company has spent a lot of time building training material, like almost to the level of like thousands of hours of training material is available. Once you pick your technology stack, then you will have thousands of hours of training material available to you. But yeah, the difficult problem is picking the right technology stack. And for that, you generally, if you're a developer landing into this team, then maybe they've picked something already and you just need to learn it. But if you have to build it from scratch, then yeah, that's an effort. There's no shortcut to learning that.
So let's just suppose if there's a CTO and the guy has been doing it in a very traditional way. Now this is this DevOps. So what would be his journey like? Going
If
back
it's
to the
really a
basics.
CTO,
Yeah.
if it's a CTO, they would know. Like, so because as a CTO, you're the chief technology officer, right? So they should really know.
They should know.
And if you're not able to figure it out, then you probably
But if
should be the CTO.
let's just suppose if there companies who are advertising for QA engineers. So what does that signify? They haven't adopted DevOps, or is it what's going on over there?
I think it's like I said, right? It's a big mix of it's a mixed bag. I mean, like even the companies that have adopted, they're like some teams that have fully adopted it, some teams have, some teams are just still very early on the journey. So it's generally a mixed bag. I mean, like just like everything software development, different teams have their own microcultures, and those microcultures are evolving at different rates, even inside of the same organization. So. But yeah, I think generally the trailblazers over here have an advantage because they're shipping code faster, and they're shipping code that is safer, and that just starts putting pressure on their other peers. So other microcultures also start adapting to this new way of doing things.
Okay, so Ali, thanks a lot for joining us. So I'll just wrap it up with this final question. Okay, so give 3 advice for any sort of like startup guy who's actually planning to get on this journey. What would those 3 major pointers would be, just to help them out with this DevOps journey?
Sure, I would say start early. So when it's just easiest to do this early, and then everybody else just adopts the culture rather than trying to change the culture later on. So even if it takes a little bit longer to roll out the first few releases, just putting in the effort to build your IAC properly and setting up your test infrastructure, as well as your applications to be built with this culture and philosophy, is going to be a worthwhile investment. So start early. The second feedback would be very clear about your metrics on which you are actually going to be measuring success, as well as metrics through which you will actually determine that your applications are getting deployed more safely and faster. So the productivity as well as the availability, you need to find out what metrics would actually would quantify success for you. And the third thing is culture. Like as you grow and the cost of success is that culture actually starts corroding around the edges. Just keep that in mind. I mean, like, this is not something that you do. It's not a one and done thing. It's not like a fire and forget thing. I mean, like, this is something that you need to continuously bring back, because if you let it lose, I mean, like, you don't keep it tightly contained with the right metrics, with the right ownership models, you would run into situations where you started off on a good foot, but even then it can actually regress into the old way of doing things. So keep an eye out for those kind of cultural regressions as well.
That's wonderful. So Ali, thanks a lot for joining us on our Xgrid Talks. So we would love to have you come here again. Maybe once you sort of travel to that part of the world, maybe we'll meet again and talk more about these sessions. Okay,
I
thanks a
would
lot.
love to. Thank you for having me.
Thank you.